Hello everyone, my name is Zhaoxing Li. I am a first-year PhD student at Durham University in Department of Computer Science. Today, I'd like to present our paper, a survey of collaborative reinforcement learning, interactive methods, and design patterns. Before the start, I would like to introduce myself. My main research interests lie in the machine learning, HCI, human AI decision making, and explainable artificial intelligence. Let's move to the introduction. With the rapid development of AI in recent years, the mainstream media has two opposing views. First, AI is described as a savior who frees humans from labor, and it is also described as the devil who takes away work's job. So is AI a savior or a destroyer? Due to the limitation of current technology, in current stage, AI often performs much worse than humans in highly complex decision-making tasks, but much better than in the task with specified feedback and large-scale data. Most computer science researchers believe that human and AI will be in a long-term collaborative relationship, so AI will be a good partner of us. Recently, the methods enabling human and AI agent to collaborate towards improving the efficiency of reinforcement learning, also called collaborative reinforcement learning. As a human-AI collaborative model usually involves two roles, the human and the AI, and the collaboration patterns between them. So we divide the articles collected into three categories. From the human perspective, we focus on how humans interact with the AI agent. This part is described in the interactive methods section. From the human AI agent, perspective, we focus on how agents accept human instruction and suggestion in the algorithm implementation. This part is described in the section 4. From the perspective of collaboration patterns, we focus on how human and AI can collaborate. This part is described in the section 6. This taxonomy could be a modeling tool for HCI researchers and designers from the DIS community to select and improve their new CIL design. AI system researchers and designers have two main tasks in recent years. First is developing new interactive technologies, and the second is applying this technology to the specific scenarios. When a researcher starts design an AI system, they could first select a collaborative model from the macro perspective in the design pattern category. Then they could select suitable interactive methods and algorithm models from the specific task requirement categories of the interactive methods and the algorithm models. So we define these three axes and populate them with representative works from the literature. So the main contribution of our paper lie in four perspectives. First, we take stock and summarize the latest collaborative reinforcement learning algorithms, define the state of art and the start of these new decades. Second, we summarize the most important human-machine collaborative patterns from an engineering perspective, which will provide better guidance for human-computer interaction researchers. Third, we have provided a new CL classification and CL taxonomy as a modeling tool to help researchers select and improve new CL designs. Fourth, we propose concrete cell challenges for future researchers in this area as a guide towards effective human-AI collaboration. Next, we move into the interactive methods. It can be divided into three types. The first is explicit method. Second is implicit method. Third is multimodal method. Explicit methods means that human provides an agent with clear numerical feedback. This method is better for the agent, which can process feedback more easily, but it causes human fatigue and thus lead to inefficiency in a long-term training process. For the implicit method, humans give feedback to AI agent through the natural interaction, such as posture and guise. This method makes higher demands for the AI agent, but it could improve the fatigue resistance for human trainers, thereby achieve long-term and stable cooperation. And the multimodal method is a method that combines different types of interactive methods. And the next is algorithm models. We classify the algorithmic models based on how agent receives human feedback. It can be divided into four types. First is reward-based methods. Second is policy-based methods, and the value function-based methods, and exploration process methods. Next, we move to the human-AI cooperation design patterns. There are many important design patterns in the engineering area. For example, the CSE patterns, the Bosch and the Brouhaus patterns, and the coactive design patterns, and the Schmidt patterns. The Schmidt pattern is the most widely used pattern in the engineering area. Schmidt's model can be divided into three levels: the argumentative level, and the integrative level, and the debative level. Next is the future work. There is a lot of work here needs to be explored. For example, how to combine different interactive methods, and how to build user modeling, how to develop safe interactive reinforcement learning, and how to develop dynamic meta models. To conclusion, we have presented a survey of collaborative reinforcement learning to empower the research into human-AI interaction and collaborative design. We also have provided a new CIL classification method, see the table 1, and the new CIL taxonomy, see figure 2, as a modeling tool for selecting and improving new CIL designs. Despite the great progress made in the field of machine learning, there are still many challenges that need to be addressed before the generic collaborative model is proposed. So that's all. If you have any questions, please feel free to contact with me. Thanks.